question number 1 is from chapter 7, gravitation, and the question is objects with masses 200 kg and 500 kg are separated by a 0.400 meter. So we have mass number 1 here, mass number 2, and this is the distance between the two masses. And the question is, find the magnitude and direction of the gravitational force exerted by these objects on 5 kg object placed midway between them. So to solve this question, we better draw the condition. So this is our M1 with mass 200 kg, and this is our M2 with mass 500 kg. Okay, and we want to find the magnitude of force exerted on another object with 50 kg, so 50 kg, the third object, which is midway between the two objects, M1 and M2. So we have here, okay, 0.2, and also we have here 0.2 meter, because the distance between mass 1 and mass 2 is 0.4 meter. So to find the forces exerted on M3, so basically we know that our M3 is attracted to object number 2, so it has force 2, 3, and at the same time our mass 3 is also attracted to object number 1, so it has forces of F13. So that is how we symbolize our forces. Okay, so to solve the first question, find the magnitude and gravitational force. So basically, force acted on object number 3 is equal to force 2, 3 minus F13. So why we have to subtract the two values? Because the direction is opposite. Because both directions are in opposite. So we need to calculate our F3 and F13. So you can directly, so now we substitute the equation G, so we write down the equation G M2 M3 over R23 squared minus G M1 M3 over R13 squared. So we continue the calculation. So we can just factorize what are the same. So we have G is 6.67 times 10 to minus 11. Okay, and mass 3 is also can be factorized. So mass 3 is 50 kg, and it is going to be mass 2, M2 is 500 over 0.2 squared minus, so mass 1 is 200 over 0.2 squared. So the answer is 2.5 times 10 to the minus 5 Newton. Okay, so that is for force exerted on 50 kg object. Okay, the second question. Okay, determine the magnitude of the resultant gravitational field strength at the midway. So again, we want to focus at the midway, but this time we want to calculate the gravitational field strength. So the symbol is A. I hope you still remember that A is equal to AG is equal to gravitational force over M. So to solve this question, as the question asks the similar position, which is at the center. So this is our mass number 1 and this is our mass number 2. Just now we have got our force at the center. So to get the value of AG, so we just used the value from the previous question, 2.5 times 10 to minus 5 divided by the mass here, your M3, so divided by 50. Okay, and finally you'll get 5 times 10 to minus 7 meter per second squared.